Our final scene-setting keynote is Mr. Stéphane Dupre-Latour. Mr. Dupre-Latour works at EDF's research division. EDF is a French electric utility with a subsidiary in Italy, Edison. He is vice president for deep tech and digital tech. Previously, he was plant manager at EDF Cattenon's nuclear power plant. From 2000 to 2006, he was advisor to French President Jacques Chirac on ecology, industry, innovation, energy, telecommunications, transportation, space, and tourism. He was the initiator of the National Road Safety Project and of the Constitutional Charter for the Environment. He is an alumni of French École Polytechnique and École des Mines. Mr. Dupre-Latour.
Dear fellows, good morning. Nuclear energy and artificial intelligence are two venerable old ladies, since they both have grown up since the 50s. Nuclear is a critical industry. AI is a critical technology too. Both brought fears and hope. And today, both live a rejuvenation phase. AI starts as symbolic, and now AI is also neuronal, like in the recent generative AI wave. Nuclear energy was a big company thing and focused on uranium fuel. Now, 100 startups explore new designs in fission and fusion area. Both nuclear and AI attract new talents and new money. So let's work together so that both fulfill their peaceful promise of social and human progress. That's why we gather today in Vienna to set the foundations for the future framework of the Agency on Artificial Intelligence. So let me suggest 8 proposals for it. 4 proposals so that nuclear could provide the best value for AI, and 4 proposals so that AI provides the best value for nuclear. These proposals reflect my own opinion as digital fellow expert and should not be taken as official position for France or EDF. First of all, as you all know, nuclear provides the best value for AI. Data centers are AI factories. They want a massive procurement of electricity for training and for inference. And soon inference will be also done inside robots, autonomous electric cars, and equipments as edge AI. This procurement of electricity has to be reliable, affordable, and quickly available. Speed is key. In France, we have a fast track for connection to the very high-tension grid. 8 sites able to receive each 1 gigawatt data centers have been identified. EDF offers its own sites that are available and already connected to the grid. They were all fossil plants burning coal or oil. EDF has already contracts with Opcore and Eclairion, and further sites will be announced next year. France exported 90 terawatts last year. It means that France can support 10 gigawatts of new data centers easily until 2030. Procurement has to be reliable. In France, we have a very good grid with a 99.9995 viability of nuclear generation and very few outages for customers. Procurement has also to be affordable. In France, the price spread with our neighbors is positive. EDF offers to data centers operators long-term contracts, sort of corporate PPA, based on its nuclear fleet. We call it CAPEN, Nuclear Generation Access Contract. Data4 already signed such a contract with us. Dalkia, a subsidiary of EDF, is also able to operate data centers utilities like cooling systems and optimize the use of the waste heat. So how much electricity will need AI? In fact, we don't know exactly, since 2 effects compete. First, the stunning improvement in energy efficiency of algorithm of processors like GPU and TPU, tensor processing units, and of densified data centers. And the second effect is the Jevons effect, with a bounce back in the use of more performant AI. So that's why projections from different studies have a wide range between low and high case. But we know for sure that the overall trend for more electricity for data centers is solid, with streaming services, web, social networks, and cloud. AI is an enabler for these services. Anyway, EDF started to build in France a series of 6 new EPR2 and plan a second series with 8 more. France will be ready to power the electrification wave. So my first proposal is addressed to tech companies. Please set up data centers in locations where there is a nuclear baseload and contract a PPA with nuclear that guarantees you access to this baseload. That's power, that's economy, that's resilience, that's peace of mind, and that's ethics also. That's ethics since nuclear provides massive, regular, and granular low-carbon electricity. Low-carbon electricity means not only zero direct emissions, but also low-carbon footprint. Footprint is based on a standard life cycle analysis, LCA, including the energy needed to build the generation plant. It could be a wind farm, a PV farm, a nuclear reactor, or an hydro dam. Low carbon means, in the European definition, less than 100 grams of CO2 equivalent per kilowatt-hours until the end of this year. Then it is planned to decrease each 5 years. The new threshold should be 83 grams in 2026 and 67 grams in 2031, and so on until 2050. EDF nuclear fleet is estimated at 4 grams CO2 equivalent per kilowatt-hour. So nuclear is for sure a low-carbon electricity for the next 25 years until 2050. But this definition is only European. So my proposal number 2 is for the agency who could push toward clear international definition of low-carbon electricity for AI and industries based on LCA international standards. With a decreasing threshold with time, it will clearly promote nuclear energy. Generation in the grid should be low carbon, but consumption by data centers should be also. Many tech companies took pledge to reach carbon neutrality in the next decade because they care about the impact of their activity and they know that customers will choose the best service. There is no room for greenwashing in the AI game. That's why a location-based accounting of CO2 should be the rule if the market-based accounting is not organized on an hourly or quarter of an hourly matching. European electricity markets run already on a quarter of an hour basis. Generation means are already equipped to cope with it unless they accept to pay during increasing negative prices, period. Smart meters for industry are already able to count on an hourly basis. So hourly matching is the near future. Carbon-free electricity 24/7 is the near future. That's exactly what the GHG protocol is proposing to fix for the accounting rules of the so-called Scope 2 for companies. Its international consultation is ongoing. Nuclear is able to deliver a hourly matching of low-carbon electricity to data centers, and so do also hydro, geothermal, and renewables if they are coupled with storage, like batteries. So my proposal number 3 is for the agency to promote location-based accounting of CO2 for data centers or an hourly accounting for consumption. It is fair, and it will clearly promote true low-carbon consumption of nuclear electricity by data centers. A small word about small modular reactors. Several letters of intention were signed about direct link between data centers and SMR or RMR, fission or fusion. Some hyperscalers even invest in nuclear power plant designer. In Europe, the Commission fully supports the European Industrial Alliance on SMR. EDF welcomes these initiatives. We don't think it will be useful in France, since the grid is robust and a free nuclear capacity is already available. But SMR for data centers could be useful in other parts of the world. Framatome and Arabelle, 2 subsidiaries of EDF, can provide robust technology for those SMR. And EDF proposed its own design for SMR, new world based on mature technologies. So my 4th proposal is to promote standards as key enablers of cost-effective buildings of series of SMR. phane code, RCC-MRX, is a good candidate for becoming an international standard for SMR. The part 2 of my keynote is about the way AI brings already value to nuclear energy and will continue to do so based on EDF's experience. More globally, industrial AI is entering a pivotal phase. After lots of experimentations and pilots, 2026 will be a year of operationalizing AI capabilities at greater scale. Many industrial AI projects were just proof of concept, since it is very difficult to go from first tasting to real industrial application. Nuclear is a critical industry. We need trust and performance with very limited hallucinations. We do not run on hype. Vibe coding is not our practice. That's why, since the beginning of AI, work at EDF is organized to focus on problem solving with several elements. First, digital factories integrated in EDF business and one for generation. They develop use cases with business-specific data and standard LLM on-premise. In the R&D division, we have 60 AI scientists and 2 philosophy doctors. We have one industrial research lab on trustworthy AI in partnership with 2 other industries, Thales and Total Energy, called Sinclair. The lab works on explicability, interpretability, and acceptability of AI. And we have our own computer infrastructure, 2 HPC clusters with GPU, and several NVIDIA DGX clusters and contracts with cloud providers. First, AI is helpful, of course, for the nuclear plants from design, build, run, and dismantle. For plants operation, there are numerous identified use cases. EDF work with American EPRI on that topic. Use case cover data and model management, asset performance, generation operations, materials analysis, regulation, and compliance. EDF already used different AI techniques, not only LLM, large language models, but also symbolic or neuro-symbolic AI, traditional machine learning, automated machine learning, computer vision, and natural language processing. We use these techniques in several domains. For example, for technical drawings, browsing, and mining of historical graphical documentation. We have tens of millions of installation plans and isometrics available only as image or PDF files. We use also AI for digital twins, like steam generator or electric alternator. AI is useful for meta-model and quick calculation using physics-informed machine learning. For visual defect detection, for example, loose foreign bodies or cracks in concrete. We use for early detection of warning signs of vibration or pumping station clogging event. For diagnostics of power plant with Metroscope, a spin-off of EDF, its solution is operational in our 56 reactors in France. We recover 100 megawatt of power on all our fleet with Metroscope. We use AI for forecasting of core actual offset, for optimizing of reactor core refueling operations, and for construction site monitoring. Second, AI should be useful also for the supply chain, for the employees, for the stakeholders, for education, for the control authorities. AI also could be a researcher sparing partner. That's called AI for science. So my proposal number 5 is that the agency enhance its leading work for the description of the use case of AI around the nuclear plant life cycle. LLM are the current wave of new generation AI. 3 years ago, in 2022, was revealed OpenAI's ChatGPT based on deep neural networks and Google's transformers dating from 2017. They made huge progress and hundreds of big foundation models are now available. They are multimodal and made impressive improvements in perception of images, sounds, and video, and reasoning and natural language processing. Now, SLM, small language model, emerge as useful tools dedicated to certain tasks. VLM, vision language model, increased the success rate of image text extraction. And new architectures are proposed like JEPA, Joint Embedding Predictive Architecture. At EDF Research Division, we are looking carefully at the capabilities of all these models, and we need to check also the sovereignty aspect. Therefore, open source is key. Industrial AI is also very useful to tackle with time series on tabular data, like maintenance data coming from different sensors or process data for anticipating failures. EDF published a foundation model for time series called MOTM, Mixture of Time Flow Models. This model is open source and was revealed at the European Conference on Machine Learning 2025. So my proposal number 6 is that the nuclear community with other critical industries should join to help to create the best time series foundation models. Today, EDF is very careful about AI, and so do the nuclear safety authorities. AI makes only recommendations to humans. We know that the next frontier for AI is to move toward decision and acting on real world. That is called agentic AI. It means that you have not only to describe use case, but also agents' mission and the required quality level of these agents. EDF is not ready to let neuronal AI make decisions for the operation of nuclear plants. We want to keep human in the loop. For the use case of agentic AI outside plant operations, my proposal number 7 is that the nuclear community should start to define specific profile for the standards of agentic AI, like MCP, Model Context Protocol, A2A, Agent to AI, and AJUI, Agent User Interface. AI is today mainly software, and it will be also become physical. AI will get body and arms, eyes, ears, and light perception, superpowers in infrared light, lidar, or radiation. And robots will get finally a decent brain. So proposal number 8, nuclear community could create guidelines and standards for the use of physical AI in nuclear plant life cycle, from building to dismantling. Anyway, security and cybersecurity in the usage of AI is a key issue. EDF launched a Center for Excellence on Nuclear Security with CEA, ANDRA, Framatome, and Orano. It is an honor to have been designated Agency Collaborating Center for Computer Security and Artificial Intelligence for Nuclear Security. The 4 years work plan focused on fostering regional and international cooperation and contributing to agency community of practice network. You are all welcome to actively participate to build a strong international cooperation on AI security and cybersecurity. Finally, machine learning is based on data. We all know the GIGO principle in data processing: garbage in, garbage out. Access to data and quality of data are key to tap the full value of data. We need efficient tools to convert unstructured data in structured data. EDF already developed tools to read all documents, all testing, all maps and schemes. They will be useful to tap all the experience from nuclear industry and academics since 80 years. AI could provide access to technical knowledge in natural language. EDF is now deploying a data platform at group level with common technical standards. And the data space for nuclear, Data for Nuclear X, was launched last month. EDF leads this consortium with CEA, DAWEX, Soprasteria, Institut Mines Telecom, and GIFEN, the French nuclear industry cluster. This data space will enable data exchange between 2,000 companies in the European nuclear value chain. Safety of data access and sovereignty are keys to create trust among all actors. It's too early for us to make a proposal on data. So here are my 8 proposals to strengthen the bonds of friendship between AI and nuclear energy. So let me finish with a light ending joke before lunch. Emmanuel Macron, our French president, said one day that the future is electrification of cars, buildings, and industries, and suggested an appropriate motto: plug, baby, plug. Since AI needs solid amount of low-carbon, baseload resilient electricity, and since nuclear fission is based on the splitting of atoms, imaginative AI generates for me a derivative motto for the coming AI decades: split, baby, split.